Good day. Good day here on ROOTCON 2022. Thanks for choosing this topic. I'm Denis from Kaspersky. Our team is responsible mostly for researching targeted malware, providing the reports about it. That's why this talk will be dedicated to the one malicious campaign we found in the wild, as usual. So it's not a proof of concept from the researcher side. It's in the wild thing. And why we decided to share with samples, with information, because one technique among all of techniques in use in this campaign, we consider it quite innovative and new. Imagine for years, malefactors tried to hide the malicious code from the plain sight of a file system, right? NTFS alternate data streams, VMI subscriptions, some encrypted scripts in a Windows system registry, whatever. For sure, these entities exist anyway on the disk, right? To make some kind of persistence, they need disk anyway. But it's not on the level of file system. It's in some proprietary format in some another entities like a system registry, like NTFS, alternate data streams, etc. With time, we found new place to hide such a code. That's why you see the name of the presentation. Let us cover, but we would slowly start from the plan for the next 40 minutes. ROOTCON gave us quite an amount of time, so let me write the plan. Also, I completely understand with most of you, we don't share the same language, so I would try to speak as slow as I can and as clear as I can. Anyway, nowadays, it's easier to find any researcher online. If any question would persist, you could ask me after the presentation or find me online for any further details. Pitifully this year, I'm not in Manila with you. I would like to, but it's a little bit crazy year. I hope to see you nearby the city on the ROOTCON different years. So straight to the topic now, and we would start with a short description how typically malware is using the logging mechanism, so put something in a log, some logging records, and how shellcodes actually already using in a malicious campaigns. After it, we would came to this new technique we considered brand new and innovative that mixed these two entities. Event logs, in this case, Windows event logs, and the encrypted shellcodes, okay? So first typical usage in this precise campaign. After it, we would provide the bird view of the campaign because for sure, much more models and technique existing in this targeted attack, right? But I would start with the most interesting one for me. But after it, we would speak about the different last stages. There are two types of the Trojans this time. Any attack end up with the last stage, right? Remote administration tool. We would describe third-party tools in use. It would be two commercial tool sets and the GitHub publicly available tool also. And some anti-detection techniques I also considered useful, maybe not as innovative as usage of the logs, but anyway, this is our plan. I hope we are good with it. And let us start from the very first point. What any reverser, any malware analyst thinks about the logging? If you are like me, taking a look all the time inside the malware, you could see the code snippets like here on this slide. So author of the software need to debug like any software developer, right? And while debugging, that bad guy could implement the approach of putting messages into log. Why not? why not? Actually, they have to remove it from the release version, right? But could you imagine the situation when everything is tested in a virtual machines, in a virtual environment, but in a combat environment, things could go bad in any place. Firewalls, bad connection channels, whatever. So I suppose some logging, which part of malware is already executed, is useful for the malefactors. That's why we made normal logging, dropping the messages to the file, to the network packets, made it all the time. Normal usage of the logs. Also, maybe in some cases, it's just keeping as a to-do, remove logging later. But so far, it's still inside the samples we observed. Nice, easier for the researcher. The matter of existence, the control of execution flow, right? Here on this slide, it's you see the part of the code regarding to the steganography. It's just taking the BMP file. It's downloaded for the microchip Trojan. It's just the decryption algorithm based on the parsing of the BMP file, right? And in the very start, this is the logging BMP get data helper. Would it help us? Yes, while it exists. Sometimes it would be wiped in the later versions when malefactors don't need it anymore, but we could enjoy some helping messages on the level of the malware on some stages of the development. Okay, I suppose enough for the typical logic. Regarding the shell codes, each of you who are dealing with the malware have seen with a part of the codes. Why shell codes are in use into the malicious campaigns? Sometimes it could be the exploitation of some vulnerabilities in a documents parser, right? Doesn't matter which, so some compiled format like a PDF, docx, whatever, and complicated parser, some errors, prompt vulnerability, and some shell code embedded into the document to expose these vulnerabilities, right? What's the difference from the normal PE or ELF files? Some techniques, the shell code have to be position independent, right? That's why always call $+5 from the slide you would get in a shell code, because position independent means the shell code couldn't use all the precious features of the PE files loader in the Windows or Windows P file loader into RAM, right? Shell code is on his own and have to understand the address and apply all these techniques. So you would see a lot of tricks regarding the getting the RVAs. You also would see a lot of parsing of the process environment block to get the addresses from the system libraries and parsing of the PE, for example, next stages, right? So quite a familiar. The last one I want to emphasize is they don't want to mention mostly the name of the functions, API functions in the shell codes. Mostly it would be the hashes. And I could tell you this code snippet we would see later in our today's talk, because it's directly related to our Windows event logs story. Okay, enough for the typical usage of the shell codes. I suppose not much new on the very first two slides, but here goes some new, at least for me, this here. Malefactors think, why don't you combine Windows event logging mechanism and the shell codes, right? Actually, why not? Imagine if you wrote the SAM driver for the Windows operating system, maybe you want to save in the logs not only the text data, not only the information messages, but also some binary part of the data, like a mini dumps. Imagine you have your users base. Users get some errors from the driver and writing to the support, oh, why? And your supporters could ask, could you please share these mini dumps for us to understand the error? So this is the part of the story about binary data in Windows event logs are completely legit functions. You could write the software and use binary part of your code in a logging mechanism. Actually, int event x files, it would be kept on the level of a file systems. But if binary part of the Windows event logs exist, why not to put some shell code over there, right? Good question. Why not? But enough speaking. It's already slide number 4. But let's go to the code from all the level of idea to the Windows API. In this presentation would be quite amount of IDA screenshots. I hope you would forgive me for the screenshots from IDA because I really needed to describe this technique. So what happens here? It's allocation over 500 kilobytes. After it, event source registered, right? Named key management service. Who knows key management service, KMS? I suppose many of you knows, right? It's once again, it's a mechanism related to the licensing of the Microsoft Office products, of the Windows operating system itself, I suppose. So KMS, one more legit source of the event logs. Okay, what happens next? And after it, I see the wild cycle in which malware reading all the messages from related to this event source, reading one after one, right? I see the keys, so sequential read. As a result, all the key management service logs would be read, and also some auxiliary task like a relocation of memory if we would need more than 500 kilobytes, and some error handling are also on your screen. Mostly we are interested in 2 API calls. It's the register event source W, let us skip W, just standing for the white, right, for the Unicode arguments, and read event log. This is it. Okay, reading all the messages from KMS, but you could ask me, if you told us KMS is legit, binary intro logs is legit, so far we see only code taking all the logs from KMS. Where is the shell code? Take a look at this filtering of all the messages getting from the Windows event logs. Filtering by event category. So they choose, authors of the malware, choose event category. On a hex level, it would be 4142 hexadecimal. In the ASCII form, it's AB. Please take only the messages. Source, KMS, category, AB. This is the interested for them. And they knows precisely KMS by itself wouldn't put any messages with such an event category. Only related to the malware would be over there. After it, put into container, in this case, it's a string from the std string, and using append method for std string, gathering all the related to the KMS event log messages with a precise known category. Okay. Next question to me could be, okay, you show us how to read, but in advanced, they has to put the messages over there for sure. Let me combine on this slide 2 screenshots. On the right, already familiar. It's a reading. On the left, it's a putting the messages, the shell code actually, to the Windows event logs. Take a look. What we have here, one more infinite white cycle, and report event. Report event, it's an API function number 3. They need to implement this technique. And besides KMS as a source, they also put like a event log information type. It would be information messages. And take a look at the start ID. after the information type, it's a familiar to us, hexadecimal for 1, for 2. It's a category argument. And message ID would be start from the 1423, the very first one. And incrementally, this shellcode would be in a ID 1424, 1425, and so far and so forth. So now we get the overall picture. Event source KMS, category for 1, for 2, starting ID 1423. Now they are ready to put into the event logs and to get and decrypt and execute. This is the most innovative actually part of the story, I suppose. For me, it was new, interesting. I tested with the code on Windows virtual machine. I mean, wrote some short code snippet using always report event, read event, register event source. No, for sure it works, because why not? It's just a normal Windows API. What was inside this shell code? They decrypted from the Windows event logs. Actually, nothing super special. You see it on a slide. Actually, on a slide where I promised you we would return to this shell code. It was the same, but on the level of the assembly language. Here, it's a decompiler. Decompiler already analyzed by me, and all the structures are marked. As you could see, quite a typical story, parsing PE, getting exports. Interesting part is the arguments of the export. The code for the exported functions of the next stage, it's ROR14, the usual algorithm. You could met it in a Metasploit, whatever, if you're using MSF Venom. It's a function, exported function named load, and arguments would be never used in the next stage, but anyway, one of the argument was a Dave, ASCII string Dave. Okay, but never used over there on the side of the next stage. So quite typical, only arguments, maybe argument and the hash of the function, which we have to brute force with the ROR14 algorithm was not so typical. All the other, you could see it in the many shellcodes. So now I think we would stop with this technique. Okay, so any questions really appreciated offline after the presentation. Okay, not offline, but in the live mode after the presentation, or find me online. Now let us move to the promised broad view of overall campaign, because you already heard some dropper, shellcode, launcher, some next stage. Let us concentrate on the different models as well. Why not? It's also interesting. What we have here, first of all, commercial toolsets. Commercial toolsets, I suppose many of you know the Cobalt Strike. Cobalt Strike was there, was in use, and also we've seen a lot of signs of a silent break. Maybe it's not the right term now, silent break, because it was a previously name of the company. It was bought by another company. Doesn't matter. On a technical level, there is an old tool with the name throwback, old version of throwback you could find on a GitHub. And we see the sites, the part of the codes of the throwbacks, the name of the models named after throwback. We have seen a lot of sign at times analyzing this campaign. And also names like Slingshot was over there, and Slingshot, it's another tool from the same developers. So we are really suppose with commercial tool set, we are basing on names and part of the algorithms like encryption algorithms. We think besides the Cobalt Strike, this tool was also in use. Anti-detection. Anti-detection was quite nice because authors now decide to use some a little bit esoteric compilers. I mean NIM and Go. languages exist already for many years, but not the most popular among the malware developers, and maybe not the most popular among the security software to detect, right? So my expectation with the stagers compiled with NIM, with Go, it just they are trying to fool the security system, trying to fool the detections, right? What was implemented in with compilers, not the last stages, some auxiliary decryptors, injectors, whatever. Not last stages was a C, C++, more traditional one. Also, interestingly, launcher, also we got the sample of launcher compiled with a GCC compiler under MinGV environment. So even if we are speaking about C, C++, more than one compiler was used. I suppose the reason is quite similar, trying to fool security solution. Last stages, I already mentioned in the very start of the story, different type of the last stager. One of them are based upon HTTP protocol and could contact external control server, but another one based on the named pipes, it's in a passive mode, just awaiting the LAN connections. So for lateral movement, another media, I could say, right, named pipes, another Trojan and common system exist in this campaign. Okay, so let us take a look at these parts one by one. Third-party tools, besides the commercial one, we also once again observe the Blackbone. Blackbone, actually not the first time we met with repository. It's previously I observed malefactors want to compile driver for injection code in the user mode in the system process driver or using the Backbone code. This time as well, just git clone, add some custom code, compile, and they are good with tool. So it's more typical among the targeted malware authors. Commercial suits, these two commercial suits at once, is less typical than usage of some prominent GitHub repository. And why we decided, let me show you one of the reasons why we decided Blackbone is involved. Take a look at this trampoline, quite typical for the Blackbone repository. They take legit file where_fault_exe related to the error handlings by the Windows operating system. Okay, copy it to another directory, to the directory with the tasks, scheduler tasks, and put some malicious DLL over there. So DLL secure the hijacking was used. If they're doing DLL secure the hijacking, they need to stop the execution of the first exe, right, of the legit exe file. So what they need, take a look, patching of the entry point of initial legit whitelisted exe, in this case, where_fault_exe. Putting the opcodes, Intel opcodes, move racks, some address, jump racks, what would be the result? It would be just on an entry point, this part of the code would change the execution flow to the provided address. And provided address is full function, which we named wait and exit. Very simple, wait for the main thread in the malicious DLL and gracefully exit process with the code 0. Familiar? Yes. If you check repository, you would see the same trampoline over there. And I already mentioned some anti-detection tricks. Let me elaborate. Besides the several compilers in use, I already mentioned on the previous slides, and the whitelisted launchers like where_fault_exe. Also, they somehow maybe obtained this digital certificate to sign the malicious files. But to my knowledge, I never observed any legit software signed with the same digital certificate, only the malicious files. So maybe they just bought the certificate to sign, somehow bought it, to take it from somewhere to sign the malicious files. Typically, if no legit software signed with it, maybe we are not dealing with the stealing of the digital certificate. Maybe it also only exists on the malefactor's side and nothing more. And patching, interesting patching, what also on board, not only the entry point of the web fault file, also I would show you on the next slide, patching of the normal event logging mechanism and AMCI, anti-malware mechanism, was patched on the level of NTDLL DLL. So NTDLL, the last level in the user space before the kernel, right? So they're working with the user space, maybe the lower level they could patch, trying to fool the AMCI mechanism or logging of the of all the infection process. Interestingly, we are already good with the keeping shellcode in event logs. A lot of details I provide, so let us skip this point. And the last one, it's an interesting name of the control server. One of the process in which they injected malicious code was a legit system in an infected corporate environment. And the registered web domain, was completely in line with the name of this infected system. So to make traffic to the external control server less visible, they even think about the web domain. I could name it quite a nice decision, I suppose. So some ROOTCON, understanding this software is on board and registering the corresponding web domain. I promise you details about the patching. Let's start with the normal event logs. As you could see, authors adore event logs, even put the shellcodes over there, but they adore only their own shellcode, only their own event logs, and not let the Windows itself to put some messages regarding the infection process. They put mention functions like ETV. ETV is a common prefix for the API related to the Windows event logging. Notification register, event register, whatever, just page to the return 0. So please don't do nothing, just return success. Please don't write any logs into the EVTX files on this infected system. And regarding the AMCI patching, it's actually, I couldn't say 2022, it's a super innovative. It's existing, to my knowledge, even in Metasploit. So AMCI patching is available for them. Good, they apply it, but it's not like the innovation technique we are starting with. All this story. I could say with AMCI patching, maybe if you have something in Metasploit, you could name it commodity, right? Many actors could, many authors of malware could apply it. And I promise you some esoteric compilers. Take a look. It's a Go wrapper. Go just decrypt the Cobalt Strike models, but it was interesting to write the script to fight with all this wrapper, because take a look, the huge amount of concatenations, really 1,000 of concatenations. After it, when you concat all this part, you have to four times debase it, the decode base 64, and after it, decrypt it with the IS algorithm. So in case of such a huge amount of blocks, I have to write some script together of this block, and after it, decrypt it. Okay, I consider it the anti-detection measure. Interesting part about the Go, a lot of usage of a syscall library. Under Windows, it was back then, it was a little bit surprise for me. Syscalls exist not only under Linux, under Windows also. It's a version specific, but it exists. You could call API functions, some API functions, using syscalls. And this Go wrapper relies heavily on Go library using these syscalls. Okay, enough for the wrapper and the patching. Patching also don't know actually what to tell much about it. Aforementioned functions like ETV event register now would be not so API event register. It would be the function returning just 0 from the malicious code. Patching also done with another, with a sample compiled, some a little bit esoteric compiler. Last stages, the last but not the least, all the attack have to end up with some remote administration tool. I mentioned HTTP-based ROT, right, and name pipe based. Let's take a look on the difference. So passive communication in the case of named pipes, it's a LAN-oriented, local area network-oriented. Passive, awaiting for the incoming connection from the already infected host. So I suppose it's lateral movement. And HTTP, it's just waiting for the connection to the C2. Interestingly, their code could handle the list of control server, and the control server from the list would be chosen randomly. So all the time, it would be not the first, second, third, some random. C2 would be chosen from the list, knock, knock, anybody home, connection. If connection not successful, next C2, next C2. If successfully, so some randomization. Quite a nice trick. Regarding the encryption, you could see it on a slide. Also, in some cases, a version would be transmitted in a beacon in initial packet to control server. Interestingly, maybe the last thing I want to emphasize here, it's besides the Windows event logs, they adore the injection. They are obsessed with injection, injecting all the system process around. So commands, command would take as an argument, I mean command from the C2 to which process, ID or name, and which code. And with Trojans, both of them you could see could inject and actually inject everywhere. LSRs, aforementioned corporate solution deployed in this environment. And the very last, it's sleep time in case of HTTP Trojan. Funny thing, sleep time, it's in configuration data, right? But they're adding a little bit randomization. The sleep time from the configuration would be multiplied to the sum range from the 0.9 to 1.1, and it means some irregularity. I suppose it's some anti-incident response measure for the incident responses would be harder to correlate the initial infection and the beaconing and some getting the commands, maybe with a little randomization of sleeping time related to this idea. Regarding the commands, quite a number of them here. You could see some special 199 terminate session. What I could emphasize here, for example, fingerprinting. Fingerprinting, interestingly, would get mesh and GUID from the Windows system registry. Nice idea, for example, to keeping its while building the unique ID for the target, maybe a nice idea to rely on the mesh and GUID. And also, even on the fingerprinting stage, setDebug privilege was taken. Is this process could do setDebug privilege? Also, interesting part of the fingerprinting. All the other comments are quite normal. You could read it on a screenshot. I think I wouldn't enumerate all of them aloud. Pipes Trojan, it's much more have a comments on board, but I personally have a feeling they have some repository from which they could construct the Trojan. For example, we observed HTTP one with the common system from the name pipes one. So they could combine building the new sample, all the part of the codes. Why not? If you have the repository, so you could. Here, It's interesting part is a number of the commands, and all the other features. What could I emphasize? For example, taking a look how long the user is inactive. So maybe they don't want to work simultaneously with the host user and wants to wait while user is somewhere not on the computer and take a look. 50 minutes of inactivity, we could send some comments to this host. Nobody is there. Maybe working like this. So actually, this is it. This is it. Really, thanks for the attention. I really hope my Runglish was understandable. If not, please ask your questions after the presentation or online. We are done. I hope we are done in time. To wrapping all up, to sum up what we have here, we described to you new techniques for the fileless malware, and also we describe the campaign, targeted campaign around it with a lot of techniques like different compilers, third-party tools, different trojans, so modern technique from the real campaign. Okay, now I'm ready for the questions. You see my Twitter nickname on the screen and my name and surname. Twitter is good. You could also find me on the other platforms. Thanks again. Hope to see you in person, and please don't forget to hug the planet further.